All right, so I'm going to go over the Unit 1 practice test. So number 1 says, here are the IQ scores of 10 randomly chosen 5th grade students. To make a stem plot of these scores, we would want to use stems. So remember, stems are the first part of the digit, and the leaves are just the last part. So in this case, the stems are the either first number or the first two numbers, and the leaf would be the last number. So for this one, the lowest stem that we would use is 9, and we would go all the way up to 14. So that would be 9, 10, 11, 12, 13, and 14. So in this case, the correct answer would be B. So the stems are the numbers to the left of the last digit. All right, so number 2, it says the ages of people in a college class the nearest year are follows. We're going to find the median age. So we're given a frequency distribution. So what we need to do here is we need to find the cumulative frequency, and that's going to help us find the total. So to find the cumulative frequency, we're going to add 15 plus 32, which is 47. Then 47 plus 27 is 74. 74 plus 15 is 89. Sorry, you might hear some noise in the background. That's my dog chewing on a bone. 89 plus 17 is 106. 106 plus 30 is 136. And then 136 plus 11 is 147. So this is a cumulative frequency, which means there are a total of 147 individuals in this data set. So to find the median age, we're going to take the total, 147, and divide it by 2, and that's 73.5. That tells me that the 74th person is the median. So looking at my cumulative frequency here, 15 people are ages 17 and lower, 47 people are 18 and lower, 74 people are 19 and lower, which means the 74th person is 19 years old. So that means the median age is 19 years old. All right, so now looking at number 3, it says if a distribution is skewed to the left, so I'm going to draw a skewed left distribution, so that means the tail is on the left. We want to know where is the mean in relation to the median. Well, remember that the mean gets pulled towards the tail, and the median is closer to the hump. So if the mean is further to the left, that means the mean is less than the median. So we're not looking at the height of the distribution. The height of the distribution just tells me how many people are there. But in terms of the value of the mean, since it's getting pulled towards the tail, that means that the mean is less than the median. So the correct answer would be A. All right, so number 4, it says the population in the United States is aging, though less rapidly than in other developed countries. Here is a stem plot of the percent of residents aged 65 or older in the 50 states according to the 2000 census. So these numbers represent the 50 states, and it represents the percent of residents aged 65 and older. Okay, so it says there are 2 outliers. Alaska has the lowest percent, and Florida has the highest. So we're looking at the percent for Florida. So it's going to be this value. So we know it's either going to be C or D. So it has to be D. And the reason I know it's D, even though there's no key, remember that percents must be less than 100. So percents are less than 100, which means that C cannot be the correct answer choice. All right, so now let's take a look at number 5. So number 5, it's asking us to find the median in the data set. So to find the median of a stem plot, we first need to find the middle position. And since there are 50 states, we do 50 divided by 2, which is 25, which means the median is going to be the average of the 25th and 26th state. So what we're going to do is we're going to count here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So here are my middle two numbers. We need to find the average. So we're going to do 12.7 plus 12.8 divided by 2. And that's going to give us 12.75. So the correct answer is going to be B. Remember, you can always check that you counted the median correctly by counting the numbers after your two middle numbers, and it should be the same amount that you counted initially. All right, number 6 says the shape of the distribution excluding outliers, and number 4 is so excluding outliers, we're going to exclude this number right here. So if we exclude 5.7, looking at this distribution, I would say that that is roughly symmetric. So C would be the correct option here. It would be roughly symmetric. All right, now let's take a look at number 7. So number 7 says to make a box plot, you must know, remember, in order to make a box plot, we use a 5-number summary. So 5-number summary is the minimum, it's Q1, the median, it's Q3, and it's the maximum. All right, so now let's take a look at number 8. So number 8 says approximately what % of individuals have below 15 in histogram B? So looking at histogram B, we're looking for below 15. So that's going to be these 3 bars. So before we figure out the percent, we do need to figure out the total in this histogram. So there's 2 in this first bar, 4, 8, 5, 2, 1, 1, 1. So the total number in this histogram is 24. So to figure out the percent of individuals that have below histogram B, we're going to add together 8 plus 4 plus 2, which is 14, and divide that by the total. So 14 divided by 24 is 0.583. which means that's 58.3%. So the correct option here would be A. Number 6 says which distribution has a higher median than the mean? So remember that the mean gets pulled towards the tail. So in histogram A, the mean is going to be closer to the tail. The median is going to be closer to the hump, and I'm just approximating here. And then in histogram B, the mean gets pulled towards the tail, which means it might be somewhere here where the median is closer to the hump. So in terms of which distribution has the higher median, that's going to be histogram A. So histogram A has the higher median because it's skewed left and the mean gets pulled towards the tail. So it's lower than the median. All right, number 10 says, which histogram have more data collected? Explain how you know. Well, we know the total number in histogram B is 24, so we need to figure out the total number in histogram A. So there's 1 here, 1, 3, 4, 6, 5, 7, and 6. And when we add those together, we get a total of 33. So that means histogram A has more data And we know this, it's because when you add up all the data or add up all the bars, it's greater than histogram B. All right, looking at number 11. Number 11 is asking us which interval contains fewer than half the observation. So first, let's figure out how much is in each bar. So there's 6 here, 9 here, 7, 5, 2, and 1, which means we have a total of 30. Well, we know the total here. So now we're going to look at the intervals. So the first interval is between 149 and 169. So I'm going to highlight that in pink. So 149 and 169 would be these two bars. So that's 16. So that's more than half, since half would be 15. So now let's look at B. B is 159 to 189. So that's this bar to this bar. So it's 7 plus 5 is 12. 12 plus 2 is 14. So that's fewer than half the observations. So the correct answer should be B. You should go ahead and check C and D. If you check C, there should be 22 people here, and D, there would be 27, which would confirm that B is the correct option because that's fewer than half the observations. All right, the next question is asking us to calculate the standard deviation using a calculator. So remember, we're going to enter this data into list 1 and then do 1 var stats. And standard deviation is SX. And when we do that, we get a standard deviation of 18.3. All right, number 13. It says test grades for a certain class were entered into a calculator and then 1 var stats was requested. The results were, and it gives us N, which is your sample size, your mean, median, standard deviation, your min, max, Q1, and Q3. It says you happen to see on a scrap of paper that the lowest grades were 35, 57, 59, 60, etc., but you don't know what any other individual grades are. Nevertheless, a knowledgeable user of statistics can tell a lot about data simply by studying the set of descriptive statistics above. So we're asking if 35 is an outlier. So remember, in order to calculate an outlier, we use the 1.5 IQR rule. So we have the quartiles. We have Q1 and Q3. So the IQR is, we're going to subtract them. 84 minus 68 is 16. And then we're going to apply the 1.5 IQR rule. So we're going to do 1.5 times IQR. So 1.5 times 16, we get 24. So that tells us how wide our fences are. So to figure out our lower bound, we take quartile 1 and subtract 1.5 IQR. So we're going to do Q1 minus 24, and then we're going to do Q3 plus 24. And that's going to give us our upper and lower bound. So Q1 is 68. 68 minus 24 is 44. So that's my lower bound. And then Q3 plus 24, that's going to be 84 plus 24. That's 108. So that's my upper bound, which means anything below 44 would be considered an outlier. So since 35, our minimum, is below our lower bound, 35 is an outlier. So I'm going to say yes, 35 is an outlier because it is lower than the lower bound. Okay, looking at our upper bound, just for good practice, our upper bound is 108, and we know our maximum is 94, so we know that we don't have any outliers on the upper end. All right, so now we're going to construct a modified box plot. So I'm going to go ahead and draw my number line, and I'm going to start at my lower bound, or sorry, I'm going to start at my minimum, which is 35, and I'm going to keep going up to my maximum, which is 94. So I'm going to go by 5. So 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. And that's how far we're going to go. Okay, and now we are going to graph this. So since 35 is an outlier, we're going to use a star to denote that. And that means 57 is going to be my new minimum. So 57 is approximately right here. So there's my minimum. Then I'm going to mark Q1, which is 68, which is approximately right here. And then Q3, or sorry, my median, which is 76, which is approximately right here. Q3, which is 84, which is approximately right here. And then lastly, my maximum is 94, which is right here. So drawing my box plot, the box goes in the middle, and then I extend for my whiskers. So there is my box plot. All right, now in terms of writing a brief description, so anytime you're writing a description, you should use SOCs, and make sure you use context. So I would say, excluding the outlier here, this distribution is roughly symmetric. So excluding the outlier, the distribution is roughly symmetric. There's an outlier. On the lower end, which is 35. The median score is 76, while the mean is 74.71. So that's shape, outlier, center, and then in terms of spread, I'm going to report the IQR. So students, actually I'm going to say that half the students scored between 68 and 84. So what I'm saying here when I say half the students scored between 68 and 84, I'm basically talking about my IQR. And then I'm also going to say the lowest score was 35 and the highest score was 94. And then last thing, I'm going to say the standard deviation was 12.61. So make sure when you are using writing a description that you make sure you use context. So I was talking, this data set represented scores, so you need to make sure you mention the fact that these are scores at some point within your description.